Welcome to probability session 5. In the last session we discussed about the tossing of multiple dice or tossing of multiple coins. Now let's take another classic example of a card is drawn from a pack of 100 cards. How many cards do we have? 100 cards. They are all numbered 1 to 100. Find the probability of drawing a number which is a perfect square. Probability of a number which is a perfect square. We don't have to say that the denominator would be 100. Why? Because there are total 100 possible outcomes. Now come to the numerator. So what are the perfect squares? Perfect squares 1, 4, 9, 16, 25. I can go up to 81, then finally 100. How many are there? There are totally 10. So I can say that the probability of getting a perfect square would be 10 upon 100, that is 1 upon 10. Let's take another case. 3 coins, 3 identical coins are tossed together. Okay. What is the probability of getting all heads? All heads. We have studied before that the total probable outcomes are 2 power n. If I have n coins, now I have 3 coins, so the total outcomes are 2 power 3, that is 8. Out of this 8, if I toss 3 coins, I know that the probable outcomes are H, 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 T, H, T, H, T, H, 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 T, 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 H, T, 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 H, and H, H, H. So what is the probability of getting all heads is nothing but P of H, 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 which is 1 upon 8, because there is only one favorable outcome. Now the next is exactly 2 heads. 2 heads. As usual, let me put denominator as 8. Now I have only 2 heads. I am not saying at least 2 heads. I am saying exactly 2 heads. Okay. So here 1, 2, 3, just 3 cases. So I can say that this is 3 upon 8. There is another case where probability of getting at least one head. This qualifies that at least one head. 2, 3, 4, 5, 6, 7, 8. Which is the case where there are no heads. I'm sorry, the last was TTT. So other than this, we can see that everywhere there is at least one head. So I can safely say that it is 7 upon 8. Now what is the probability of getting at least, mark my word, at least 2 heads? So here there are 2 heads, there are 3 heads, but at least 2 heads. So this qualifies 1. So let me put 1, then 2, then 3, then 4. No, 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 no. So it is 4 upon 8. Are we getting it? Similarly, probability of getting all tails is just one option, 1 upon 8. We have seen in the classic case of rolling of 2 dice that you can get 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. These are the 36 options, 6 power 2 when I roll 2 dice, which I am going to get. Now somebody asked me, what is the probability of getting multiple of 2 on the first die? Please understand what I'm saying. Probability of getting 2 power something, sorry, 2 into something, that is multiple of 2 on first die and multiple of 3 on second die. As usual, let me write denominator as 36. I am not going to disturb this denominator because there are total outcomes are 36. Now multiple of 2 on the first die. Now let me only scan the first part. So you can see that in this entire row it's going to be 1. It's not a multiple of 2, but here yes it qualifies. This entire row qualifies. So that means I can have 6 options here. Correct. This doesn't qualify. Similarly, this qualifies because I'm in these all 6 options I'm going to have 4 on the first die. This is not going to qualify and this is going to qualify. Agreed. So I have 6 plus 6 plus 6. So 2 on the first side. So I have totally 18. Here I have 18 occurrences. What about this? Multiple of 3 on the second die. So I cannot take the entire 18 as favorable outcomes. So out of this 18, so I should choose only these 3 rows because I should eliminate the other rows. Out of these 18, how many have multiple of 3 on the second die? So if I scan this, I get one guy here, another guy here. So you can see that multiple of 3 can happen only in this column or in this column. And out of the 6 columns I have already ruled out, in this I have ruled out 3 rows, so I should only look into this row and this row for the second die which is having a 3 or a multiple of 3. So out of 18 I automatically qualify 4 occurrences from each row. So I have 3 rows and I have only 2 persons who are qualifying from each row, right? Slightly tricky problem. So I know that 2 plus 2 plus 2, I have only 6 options. So the probability is 1 upon 6. Do we get this? This is very important. This is called some condition. Multiple of 2 on the first and multiple of 3 on the second. So the probability is very clearly, see, I have this guy here, I have this guy here. Similarly, I have this guy here, I have this guy here. Similarly, I have this guy and this guy. All others are qualifying the first condition, but they do not qualify the second condition. So I have only 6 options out of 36, so it is 1 upon 6.